Using inverse functions. Well, we're asked to solve this. Notice they didn't give us any restricted domain, so let's assume it's negative infinity to infinity. All right. Well, we've got two different trig functions, and we can't factor anything. So, whoa, wait a second. We do know that secant squared x is equal to 1 plus tangent squared x. So if I make that substitution there for secant squared x, I can at least get it all in terms of tangent. So this is 1 plus tangent squared x. And now I'm going to drag everything to one side. So this is going to give me tangent squared x minus 2 tangent x. If I have plus 1 minus 4, when I bring that over, that'll give us minus 3 equals 0. Oh, please let me be able to factor this. Please, please, please let me be able to factor this. Tangent x and tangent x. Now, factors of 3 are 3 and 1. And I want a negative in the middle, so I'll go negative and positive. Let me make sure I can FOIL to check. Tangent times tangent is tangent squared. That's first. Last is 1 times negative 3 is negative 3. I'll have tangent x minus 3 tangent x is negative 2 tangent x. Now I've set up my zero product property, which allows me to say tangent x plus 1 equals 0 and tangent x minus 3 equals 0. So if I add 1 to both sides, if I subtract 1 from both sides, then I'm talking about this. ASTC, where is tangent positive? Here and here. So where is it negative? Here and here. Whoop. We did a problem very similar to this just a moment ago. So where is tangent? Remember, that's opposite over adjacent. So that is root 2 over 2 and negative root 2 over 2 and 1. And here will be positive root 2 over 2 and negative root 2 over 2 and 1. So I can say x is equal to, I'm going to pick this one. If our reference angles are pi over 4, then I'm going almost over to 4 pi over 4, which is 1 pi, but I'm going to back it up 1 pi over 4. So that's 3 pi over 4. Now, look at these are directly across from each other. To get to the next solution, I'm just going to add pi n. And so there is one solution. Now, I don't have to resubstitute or anything because I was just given x. Here, tangent x equals 3. Well, I don't have any special triangles that give me 3. Note, if this were sine or cosine, then my ratio better be between negative 1 and 1. But for tangent, the ratio is anything from negative infinity to infinity. So you can't give up on this and say, oh, no solution. That's only for sine and cosine. So here I'm looking at this and saying, well, I can say x is equal to inverse tangent of 3. So x is equal to, when I do this in radians, I get 1.25. Now let's look at what's going on here. If we take inverse tangent of 3, don't forget, we have to block out this side of the moon, and then we have an open circle at negative pi over 2, open circle at pi over 2, and I'm asking, where is tangent positive, ASTC? It's up here. So we get this angle here. Remember, pi over 2 is 3.14 divided by 2. It's about 1.57. So you can see that if our angle is 1.25, it's going to be in quadrant 1. But now that we get that one answer, let's find out our infinite answers. Well, I find out that the answer is 1.25. From using my inverse tangent. That's one answer, is that I have 1.25 radians. How do I get this answer? Because all students take calculus. Here, tangent is positive in both of these quadrants. So to get from here to here, I have to add pi. To get back, I have to add 2 pi. So I can say 1.25 plus pi n. Again, when you have tangent and cotangent, and in some other circumstances too, if the answers are directly across the unit circle from each other, then to get to the next answer, you're not having to add not having to add 2 pi, but rather just 1 pi. So the only thing different about this problem here is that we don't have a unit circle for when the ratio is 3. It's not one of our special triangles. So you have to recognize, 1, that you have to use your calculator. 2, that although you have to use the dark side of the moon, then you have to extrapolate and say, well, I also get the solutions across the unit circle from this, and then add the pi n to signify. Sorry about that. To signify that you understand that there are infinite solutions to this. You only get one solution to that tangent problem. Why did we only get one solution there? Remember, we had to restrict the domain and the range of the original tangent function. So if we're asking where does tangent equal 3, remember this was our original domain restricted from negative pi over 2 to pi over 2 function. And we're saying where does it equal 3? And we look at the x, and that was 1.25. But that's not the only answer if we're using an infinite domain. That's why I'm saying first find that one answer and then add pi n to it.